Welcome to the notes on rewriting expressions hard. So this is the fourth lesson. So yours should have a number 4 on top. Okay, so in our last lesson, we learned these first 3. I'm just re-bringing them up right now to remind you. So it says the review of the exponent rules that we've already learned plus 2 more. So the one we learned yesterday was the exponent product rule. And remember, product is just a big word for multiplying. And what it says in the rule is if you have some number to the power of n times the exact same number to the power of m, a different exponent, what you do with the two exponents is you end up adding them. So remember, in words, it was when multiplying, add the exponents. So for example, 4 squared meant 4 times 4 times 4 to the power 7 meant that there are 7 more. And altogether, there's 9 of them. So it ends up becoming 4 to the power of 9, which if you look at your exponents, that's just what happens if you add 2 plus 7, that is 9. So the second rule was the exponent quotient rule. And quotient was just a big word for divide. And it said if you take some number to the power of n divided by the same number to the power of m, what you end up doing with your exponents is you subtract them. So in words, it's when dividing, subtract the exponents. So for example, if I had 3 8s on top, so 3 times 3 times 3 divided by 3 squared, which is 2 3s on the bottom. These two turn into giant 1s. They can cancel and go away, so I end up with 1, 2, 3, 4, 5, 6 3s. So my answer ends up being 3 to the power of 6. But if you look at the numbers 8 and 2, 8 minus 2 becomes 6. So with your exponents, you just end up subtracting them. Next is the exponent power rule. That just means an exponent on top of an exponent. For example, if you have b to the power of n, and the whole thing's in a parentheses getting raised to the power of m, you end up multiplying your two exponents. So in words, it's when exponent on exponent, multiply them. So here I have 5 cubed, all being raised to the power of 4. That means I have 4 5 cubes, but each 5 cubed turns into 3 more 5s. So 5, 3 from that one, times 3 from the next one, times 3 from the next one, times 3 from the next one, gives me a total of 12 5s. So it's 5 to the power of 12 because you end up multiplying the 3 and the 4. So we have 2 more rules to add today. One is called the negative exponent rule. And so basically, here's what the negative exponent rule says. If you have b to the power of negative n, you can rewrite it as 1 divided by b to the power of positive n. So if that doesn't quite make sense to you, here's the best way to explain it. Any number in the world, like I'm going to jump down here. For example, the number 5, I can make it a fraction, always, by dividing it by 1. Because anything divided by 1 is itself. So if I have some number, I can always make it a fraction by dividing it by 1. And if my exponent is negative, then my term is not happy. For example, if this 5 had a negative 2 on it, it means that 5 is not happy. It's not happy where it's at in the fraction. Meaning right now it's on top of the fraction, it's not happy there. So what does it want? It wants to be on bottom. So this 5 squared wants to move to the bottom. And now the exponent's not negative because it's happy. It wants to be down there. So once you move it, you change it to become a positive exponent. Note that there's still this 1 on bottom, but 5 squared times 1 is just 5 squared. Also, anytime every single number is being times by 1, So when I move this 5 squared to the bottom, there's still that 1 on top. Okay, so in words, we can say if the exponent is negative, it is not happy. So move it. So move it and make it happy. So this 9 to the negative 3, it's not happy on top. Because remember, every number, if there's no fraction, you can divide it by 1. So it's not happy on top. It wants to move to the bottom. So once it moves to the bottom, it's happy. So the 3 is not negative anymore. It's just 9 to the power of 3. And because we moved it from the top, there's nothing left on top except for the 1. Because there's always a 1. Alright, and finally, the 0 exponent rule. Here's what it says. It says b to the power of 0 equals 1. So, meaning anything to the power of 0 equals 1. Alright, that might feel a little bit confusing, like why isn't it 0? Why is it 1? And so I'm going to explain that really fast. If you go into the example, it says 3 to the power of 8 divided by 3 to the power of 2 to the power of 4. You times those, remember? So it's also 3 to the power of 8. Right? And if there's 3 8s on top, 1, 2, 3, 4, 5, 6, 7, 8, and 3 8s on bottom, well, a 3 over 3 is 1. Times 1, times 1, times 1, times 1, times 1, times 1, times 1. They all cancel out. And 1 times 1 times 1 times 1 times 1 is just 1. Equals 1. Because anything divided by itself is 1. 5 divided by 5 is 1. 10 divided by 10 is 1. So 3 to the power of 8 divided by 3 to the power of 8 is 1. Because it's the same on top and bottom. However, remember our division rules. This means when you're dividing, you should subtract the exponents. So 3 to the 8 minus 8. So because I'm dividing, I should subtract. So 3 to the 8 minus 8 is 3 to the power of 0. Because 8 minus 8 is 0. But as we just showed you here, that is 1. And it's because anything to the power of 0 is 1. Okay. So one thing that makes these harder is adding in these two rules. Another thing, go ahead and flip your paper over, that makes it harder is that sometimes, I'm reading here, sometimes the base won't always be the same. But they have to be the same in order to use these rules. So in order to make them the same, it's okay to turn the bigger number, so we're taking the bigger one always, and turn it into an equivalent expression that has the smaller number instead. For example, 9 is the exact same thing. Can be turned into 3 squared, because 3 times 3 is 9. Okay? So I'm going to jump to the bottom of this page and show you how to use this table. So this is x, just x alone. If x is just alone and it's 2, then x, if I square it, 2 times 2 is 4. And if I cube it, 2 times 2 times 2 happens to be 8. And if I do it to the power of 4, 2 to the power of 4 is 16. 2 to the power of 5, meaning 2 times 2 times 2 times 2 times 2 is 32. And if I times it by 2 again, I'd get 64. If I did the same thing for 3, if I square it, I'd get 9, because 3 times 3 is 9. If I cube it, so I times 3 again, it's 27. If I do that again, times 3, it's 81. And then if I do 81 times 3, I get 243. And then if I times that by 3 again, I get 729. Meaning 3 to the power of 6, because of that little x6, is 729. Feel free to fill out the rest of this table so you have it as a tool. If we hit one on here that we need in the table, I'll fill it out, but otherwise you should just fill them all out. You just do 4 times 4 again would be 16, times 4 again would be 64, and you just continue timesing it by 4 until you get to the x to the power of 6 and do it with the 5s and the 6s and so on. So let's do example number 1. So example number 1, I have a 7 and a 49. Well, I can't just add the exponents because this says I have 4 7s and this says I have 9 49s. I can't count how many, I can't put those together because they're different numbers. What I can do is go over to my 7s though. Well, 7 times just one time is 7. 7 times 7 twice though is 49. So here, I still have 7 to the power of 4 times, instead of 49, I'm going to rewrite what that 49 is. Now no, I just put a parenthesis at first because I want to make sure that I'm raising it to the power of 9 because 49 is still having an exponent of 9. It's not going to disappear. However, 49 is going to turn into 7 squared. Because if you put 7 squared into the calculator, 7 times 7 is just 49. So I'm not changing this number. It's still 49. I'm just rewriting it as 7 squared because it's the same thing. And what it does is it allows me to have both of these being 7. So now I can use all my rules. So first, 2 times 9. So I still have 7 to the power of 4, but 2 times 9 is 18. And now I have 7 to the power of 4 times 7 to the power of 18. And remember, when you multiply, you add your exponents. So you end up with 7 to the power of 22. Okay, I'm going to move to number 2. I have a 10 and a 100. Well, if I look at my tens list, 10 times 10 is 100. So 100 is 10 squared, because it happens twice to get 100. So I'm going to rewrite it 10 to the power of 5 times 100 cubed. But instead of 100, I'm writing a parenthesis because I want to change 100. And what is 100? 100 is the exact same thing as 10 squared. So I could replace 100 with 10 squared because now I'm working in both tens. So then I still have 10 to the power of 5 times these two exponents I multiply, so it's 10 to the power of 6. Then now that I'm multiplying two tens with exponents, I add those exponents. So I get 10 to the power of 11. Alright, I'm going to circle my answers so fast. Alright, so the next one, I have an 81 and a 3. Well, the bigger number becomes a smaller number, so 81 to the power of 5 is going to change to something. And I still have 3 cubed on bottom. But that 81, I don't want to be an 81. I want it to still be 81, but I want it to look different. And if I look at my list, 3 is the same thing as 81 to the power of 4. Alright, so instead of 81, I can write 3 to the power of 4, because it's the same thing, but now they're both 3's. So then, I multiply these two, because it's exponent on exponent, and get 3 to the power of 20 over 3 to the power of 3. And finally, because I'm dividing, I get to subtract my exponents, so it becomes 3 to the power of 17, because 20 minus 3 is 17. Okay, for number 4, I have a 3 and a 27. Since the bigger becomes the smaller, I'm going to change 27. So I still have 3 to the power of 4 on top over 27 squared. 27 I made a parentheses because I'm going to change it. And 27 in terms of 3 is 3 cubed. So it's 3 cubed. They're the same thing. So now I always do my multiplying part first because the exponent on exponent, so I still have 3 to the power of 4 over 3 to the power of 6 because 2 times 3 is 6. And now I subtract because that's division. So 3 to the 4 minus 6 is negative 2. Well, now I have a negative exponent, and that means it's not happy on top. So I want to move it to the bottom and square it because it's a squared. And my 2 is going to become positive now because I moved it, and there's still a 1 on top. Another way to think about that is I had 6 on bottom and only 4 on top. So when they all canceled out, I would still have the 2 3's left on the bottom. Okay? So now that we're in this whole negative exponent thing, remember this 5 to the negative 3 means it's not happy on top. It wants to move to the bottom. So you move it, and you make it positive because it's happy now. And there's still a 1 on top. For this one here, it's not happy on bottom because it's negative when it's on the bottom. So I want to move it to the top. There's still a 1 up there, but times 1 means nothing. It's like the same thing, so it's just 6 squared. But it's a positive 2 because I moved it, so it's happy. And since I moved it away from the bottom and there's nothing left on there, it's just a 1. And 6 squared divided by 1 is just 6 squared. Okay. So now for 9, I have a 25 and a 5. Well, if I had my 5s filled out, I would see that 25 is 5 squared. Because 5 times 5 is 25. So instead of 25, I'm going to write 5 squared. However, remember 25 is being squared. So if I'm writing 5 squared, I still need to square that because 25 is being squared. Over 5 to the negative 3. Now I do exponent on exponent, which means I multiply them. So I get 5 to the power 4 over 5 to the negative 3. Okay? Well, this 5 to the negative 3 is not happy on bottom. It doesn't want to be there. It wants to move to the top. So I still have 5 to the power of 4 on top. And then I'm also going to add 5 to the power of 3 on top because it wants to be there. And then you divide it by 1 because there's nothing else on bottom. So now these two are being multiplied to each other. When we multiply two numbers, you add their exponents. So you end up getting 5 to the power of 7 divided by 1. However, anything divided by 1 is just itself, so it's 5 to the power of 7. And finally, for number 10, you just go term by term. Y squared, it's positive, it's happy on top. Leave it on top. However, the x to the negative 6 is not happy on top. It wants to move to the bottom, so I'm going to move it and make it happy, so the 6 is now positive. Moving to the bottom, the y to the negative 4 is not happy on bottom. It wants to move to the top, so we're going to move it to the top and make it happy, meaning that 4 is now positive. And then the x squared, it's happy on bottom. It wants to stay there, so we're going to keep it there. Now, I have two y's being multiplied, which means I'm allowed to add their exponents. So I have y to the power of 6. And then I have two x's being multiplied, which means I'm allowed to add their exponents. So I have x to the power